Hello to all you gorgeous Godotians and unified Unitarians, and welcome back to another video by Game Dev Journey. Today I'm comparing how easy it is to implement a kinematic bouncing ball in Godot versus Unity. At the end of the video, please comment on which engine you think it's easier to use. Please remember to like my video if you enjoy my content, and consider subscribing if you would like to see more videos from me in the future. Every new subscriber encourages me to keep creating content, and it truly warms my heart. The footage in the background is of the game Sealed Bite by Securus. It is proudly made with Godot, and I encourage you to check it out on itch.io by following the link in the description. And now, on to today's video. We'll start off by making a world for our game to exist in. This is just a 2D node and we'll name it world. We'll then add a ColorRect to this world, which we'll use for a black background. So we'll search for ColorRect, select it, and let it fill the entire viewport, and we'll change the color to black. Today we'll start with something a little different. If you're familiar with other object-oriented programming languages, I found it really interesting that nodes are basically just classes, and so we can make our own nodes by defining a class. You'll see I'm making the paddle, which is a kinematic body, and we'll add a sprite to it for some texture. I've got a red paddle image which I'm going to use as the texture for this sprite, so I'm just going to drag that onto the texture slot. We need a collision shape, so I'm going to add a collision shape 2D, and because this sprite is rectangular, I'm going to make the collision shape a new rectangle shape, and I'm going to resize it so that it fits the paddle nicely. Then I will group all of these together so that we can move them as one object. Now we'll save it as a paddle scene. Now to create our own script or node, click on Script at the very top, and then click on File, New Script, and give your script a name. I'm going to call mine player input, and now we can hit create. Let's get rid of this code we don't need, and let's declare our class. Make sure your class name is the same as the name of your script. The class name will become the name of the node. Let's create a variable for the player. The type for the player will be kinematicBody, and it's going to inherit its type from its parent node. So in our ready function, we say the player is equal to getParent. That will make sure that the type for the player is whatever the parent node is. In this case, the parent node for the paddle is a kinematicBody. Now we'll make our own function to handle input, and this is just to make sure we can move the paddle up and down when we press the up and down keys. We need to get a direction vector for the paddle, so we set it to vector 2, but we're only going to use the vertical direction, the Y. So if they press up, we'll decrease Y by 1. If they press down, we'll increase Y by 1. Now we're going to add a script to our paddle, so click on the attached script, click on paddle, get rid of this code we don't need. So you'll see that our paddle extends kinematicBody2D. That's because the paddle is a kinematicBody2D node. What we're going to do now is create a variable for the speed of the paddle and set it to, say, 400. We can always change that, and create a variable for the direction of the paddle. Again, this is a vector 2, so we have an X and a Y value. Because the paddle is a kinematic body, a physics body, we can use the physics process function, and we can check to see if it is moving by checking the length of the direction vector. we normalize that so that the speed is the same in all directions, and then we multiply it by the speed. And we use the move and collide function to detect collisions. You'll see when we run the scene, we can't move the paddle, so there's something missing here. And what we need to do is update the position of the paddle. So we need to emit a signal that tells our node, which we made, to update the position of the paddle. So we'll add in a little signal at the top here, and we'll call it update. And then what we'll do is we'll connect this signal to our node, but first we need to add the node that we made to our paddle. So what we need to do now is go and add our node like any other class. You'll see we can't connect it because we don't have the custom node that we made yet, so we need to go and add our custom node by clicking on the plus to add a node. We can go and search for it. We called it player input, so if we just start typing player, we'll find it here at the bottom. Click create. Now we've added our custom node to our paddle. Now we can connect our signal to that custom node. Click on update, click on connect, choose our custom node, and there we go. So when this player node, custom node, receives the signal, we run our handle input method. And now when we run the scene, we should be able to move our paddle and have nice smooth movement. Now let's go and see how easy it is to do the same thing for the paddle in Unity. Right, here we are in Unity, and I've got to say it was much easier to do this in Unity than Godot. First thing we'll do is create the black background by clicking on the camera and changing the color to black. And we'll drag in our paddle as a sprite. Zoom in a little bit. Let's rename it to paddle. Let's create a new C# script for the paddle and name it paddle to match the name of the game component. Let's go into adding a physics 2D body. We'll add a rigid body 2D for the paddle, and we'll disable gravity so that it doesn't fall down. Let's also add a box collider 2D so that the paddle can collide with the ball. Let's just resize that collider so that it matches the paddle very closely. Now let's go into the script. Let's add a public variable for the speed that the paddle moves, and let's also add a variable to represent the rigid body of the paddle. Let's add a private variable for the movement direction of the paddle. Now in the update method, what we're going to do is we are going to get the vertical direction for the movement variable, and then we're going to use that to multiply it by the speed of the paddle. Now we need to attach a script to the paddle, so let's drag the script onto the paddle, and what we then do is the variables, we'll set the speed to 5 and we'll drag the rigid body into the rigid body variable. Now if we run it, we should be able to get some nice smooth paddle movement. We're going to create the walls, so let's start by making an empty game object, and let's call it walls. Now I'll create another empty game object inside walls, one for each side, left, right, top and bottom. Let's call this one left, and all we're going to do is add a box collider to it. This will be an invisible collider that the ball can bounce against. Let's resize it and position it. We'll duplicate it for the right hand side. We now have a collider for left, right, top and bottom. Let's add the ball to the scene and let's resize it. 0.1 is too small, let's make it slightly bigger. How about 0.2? And let's position it in the center. And zoom in. Now we're going to add a rigid body component to the ball, and we're going to make sure we turn gravity off so that the ball doesn't fall. We're also going to add a circle collider 2D to the ball so that it can collide with the walls. Let's just make sure that that collider is perfect. Now we will add a script to the ball, so click on create C# script. Let's rename it Pong Ball to match the name of the sprite. Let's open the script. Let's add a public variable for the speed and another variable to represent the rigid body of the ball. Let's create a method called launch to launch the ball. And what we'll do is we will have a variable for the X and the Y, which will pick a random number between 0 and 1. Now if X is 0, we'll set its value to -1, which means it's moving left. Otherwise we'll set its value to 1, which means it's moving right. And we do the same for Y. Then all we have to do for the rigid body is set its velocity to the speed X times speed Y. Now all we need to do is attach our script to the ball and then go and set the speed to say 5 and attach the rigid body game object to our variable. Don't forget to go into your script and call the launch method from the start method. This will allow the ball to launch when the game runs. So if we go ahead and run, we should have a ball that bounces around the screen now and can collide with the paddle. Okay, we forgot to add the bouncy physics material to the ball, so let's go and do that. Create a new 2D physics material, let's call it bouncy material, and set the bounciness to 1. And now it should be able to bounce. So let's go ahead and run it again. Attach that bouncy material and run it. And now we have it bouncing off the walls. Let's see what happens when it bounces off of the paddle. Let's see when it hits the paddle that the paddle goes flying. Now the reason for that is because the paddle's body type is dynamic. Change it to kinematic and it will no longer react that way. And there we go. Done. Right, we're back in Godot and let's create a scene for the ball. The ball will be a kinematic body, so let's select that as the root node. Let's rename this node to ball. Now let's add a sprite node so that we can give the ball a texture. Let's drag in the texture we have to the sprite and let's resize it in the transform. Set the scale to 0.2, just like we saw in Unity. Now let's make sure that we have a collision shape for this kinematic body. So let's get a collision shape 2D and let's select a new circle shape and let's just resize it to fit the ball correctly. Now we will group all the components together so they move as one, and let's just move the ball into the viewport a little bit. And now let's add a script to this ball. So let's click on attach script, ball.gd is fine. Let's now delete what we don't need and start adding in our code. first thing we'll add is a variable for the speed of the ball. Now we'll add our ready function, and inside our ready function we're going to randomize, because remember we're going to pick at random which direction the ball moves in. We'll also create our own function which will set the start direction for the ball. The way it'll work is we'll pick a random x value and we'll use the rand_i function to do it. So there'll be a 50% chance the x will be a 1 or a -1, a left or a right. We'll then set the direction to that random x position, and then we'll choose a random position for the y between -1 and 1 using random range. It looks like we've forgotten to add a direction variable, so we'll go and add that just underneath our start speed. And there we have it. Now I see we've called our variable start speed, but we're trying to refer to it as ball speed. So let's rename our start speed variable ball speed. And it should pick it up now. Now we can call our set start direction in the ready function. In our physics process, we can detect the collision using move and collide. And if there is a collision, then we must bounce off the object we collided with, and we get the normal of the collision object, which just means we get the angle of the surface so that we can leave that surface at the opposite angle. Now if the collider is in the group paddles, we're going to do something. Now we need to add the paddle to a group called paddles. So we'll go and add a group called paddles to ensure that the paddles are part of that group. Now back in the ball script, if the collider is in the group paddles, then we want to move off of the paddle, and let's say we halve the velocity. And what we can do is set the speed that we move off the paddle to the ball speed times by the direction. Now we need to create a new scene which contains the walls which the ball will bounce off of. So let's go and find a static body 2D and create that node as the root. Let's then just rename it play area, and all we'll do now is add collision shapes to this play area. We'll make them rectangle shapes, and we'll just put them on the left, on the right, at the top, at the bottom, and we'll just duplicate them and rotate them to make it easier to put the play area together. Let's call this one the top, we'll duplicate it and just pull it down, and we'll call this one the bottom. Now let's duplicate the bottom and rotate it 90 degrees, and we'll move it across to the right and call it right. We'll duplicate the right wall and move it to the left and rename it left. Now we'll save this scene as play area. We'll go back to our world scene, and in our world scene we'll instance a ball, a paddle and a play area. We'll put them all in, we'll play the world scene. Now you'll see the ball bouncing off of the walls, and it should be able to bounce off our paddle too. So I think Unity is easier in this case, but let me know in the comments what you think. That's it for today's video. Once again, I'd just like to say thank you so much for joining me. I really do appreciate the support, and I hope to see you again next time. Goodbye.